Hello everyone, myself Utsaveta. Welcome to the second video of Mensuration series. In this video, we are going to cover more important and interesting topic like video 1. If you are new and you haven't seen video 1, then in the description, you will get the link of video 1. So just rush over there, first see the video 1 and then come back to the video 2. Because if you want to be master mensuration, then you have to be with the complete information. So in this video, we are going to look the area of polygon. Now what is polygon? Poly means many and gon means sides. So togetherly, polygon means many sides. And when I collect polygon with mensuration, that means any figure with many sides are known as polygon. Now in this polygon also, few figures have been defined. Like if you are having 3 sides, it is known as a triangle. If you are having 4 sides, it is known as a quadrilateral. If you are having more than, or you can say if you are having 5 sides, it is known as a pentagon. So this way, all the sides have been named. But in this video, we are going to talk about quadrilateral 4-sided figure. In this quadrilateral, square, rectangle, then irregular 4-side, everything we are going to see over here. Moreover, the next thing which we are going to cover in this video, that is polygon, many-sided. It can be 5-sided, it can be 6-sided, it can be 7-sided, it can be 8-sided, it can be how many sides we want. But in this video, we are going to find how to find the area of a quadrilateral. Not a regular quadrilateral, irregular quadrilateral, because regular quadrilateral you all are aware, that is a square. How to find the area of a square? Area of a square is side into side. We are also not going to talk about the area of rectangle, because that also you know. What? That is area of rectangle is length into breadth. So here we are going to take an irregular quadrilateral, and how can we find the area of that we are going to see. Moreover, we are going to take an irregular polygon. So let's begin our video with this concept. So this is my quadrilateral and we are going to find the area of quadrilateral. Before starting this, let us first derive the formula, how the area of quadrilateral formula came into the picture. AB, BC, CD and AD. This is the 4-sided figure which we call quadrilateral. If I want to find this area, this is an irregular because it is not a rectangle, it is not a square. So I can divide this quadrilateral into 2 parts, drawing one line which joins the opposite vertices, that is A and C. Now this whole quadrilateral has been divided into 2 parts, that is 2 triangles, that is triangle ABC and triangle ADC. And if I want to know the area of quadrilateral, which is equals to the area of triangle ABC plus area of triangle ADC. So over here, if I go with the area, then formula of area of triangle is half into base into height plus half into base into height. The formulas are going to be same for both the triangles. If I take a triangle ABC, then this AC is going to be my base. So I'm going to write over here half into base is my AC into what's going to be my height, the vertical perpendicular line drawn from P to AC is known as my height. Let us name it as ABE. So BE is my height in the triangle ABC. Same way, plus half into base. Now in ADC, it's very simple that AC is going to be my base. Same way, to find the height, I'll drop one perpendicular line from here, naming it F, that is DF. So at the place of height, we'll write DF. Now if you focus over here, then this half and half are common. AC common. Now nothing is common, we'll draw the bracket. In this first bracket, BE is left. Between plus sign in the second bracket, DF is there. Let us draw this way. That means half into, what's my A? Half into AC. Now this AC is nothing but it's a base of both the triangles. Or we can also say that this AC is the diagonal. You know what is diagonals? A line segment which joins the opposite vertex, or you can say alternate vertex of any figure, that is known as a diagonal. So this AC is diagonal. Write it D. BE is my height. Same way, DF is also my height. That means this both are height. Then can I name this as a height 1 and this as height 2? That means BE is my height 1 plus DF is my height 2. That means the formula is half into diagonal into height 1 plus height 2 is nothing but it's the formula to find the area of a quadrilateral. Which type of quadrilateral? Which is irregular. It has a 4 side but it is irregular. That type of quadrilaterals, if we want to find, we will use the formula that is half into diagonal into height 1 plus height 2. I hope that this derivation is clear to you, that how we have derived the formula of quadrilateral, that is irregular quadrilateral, that is half into diagonal into height 1 plus height 2. This you can relate as the formula of triangle also. This is a reference to remember, you can use, that is half into base into height. This you can use as a reference. Half as it is, base. What's the base of both the triangles? That is diagonal. So diagonal over here, height. So we are having a 2 heights. So half into diagonal into height 1 plus height 2. So you can use the reference formula to remember, that is half into base into height. Base is nothing. The base of both the triangles, that is diagonal. And the height, we are having 2. That means height 1 plus height 2. So I hope that this is clear to you. If you have any doubt, then comment it. If you don't have any doubt, but you have understood this very properly, then yeah, like the bantai to motivate me to bring more interesting videos just for you. So let's begin more in this video. Now moving further to this video, now we are going to talk about area of irregular polygon. This section does not have any definite formula, because according to the figure, the formulas have been generated. This is an irregular polygon. Polygon means many sides. That means this figure has many sides. 1, 2, 3, 4, 5, 6. 6 sides are there. But this is not a hexagon, regular hexagon. Same way. 1, 2, 3, 4, 5. This is not a regular pentagon. This is some irregular polygons. Now, the area of irregular polygon depends upon the shape. Like if I talk about this first shape, then this first shape, if I see, then this shape has been created or constructed with many small shapes. If I talk about this first, it is made up of triangle. If I talk about this second, it is made up of trapezium. If I talk about third, again it's triangle, fourth triangle. Fifth one is rectangle and sixth is triangle. So this single polygon is made with the 6 shapes. 4 triangles, 1 rectangle and 1 trapezium. So when we find the area of irregular polygon, we need to first apply area of triangle 1, area of trapezium, area of triangle 3, area of triangle 4, area of rectangle plus area of triangle 6. Once you find the individual area of all these shapes, at the last you add the area of all these 6 shapes, and the ultimate answer what you got, that is the area of your irregular polygon. So your formula is not defined. Same way if I come over here, it looks like a house which we used to draw in the small grades. This has been constructed with 1 triangle and another 1 square. So here the area of irregular polygon becomes area of triangle plus area of square. Same way, if I come over here, this is an octagon, 8-sided figure. If this is an octagon, then it has been constructed with first trapezium, second rectangle, and third also trapezium. That means area of this octagon equals to area of trapezium 1 plus area of rectangle plus area of trapezium 3. And when you add up, you will get the area of irregular polygon. That means that the area of irregular polygon depends upon the shape. Clear? How that shape has been prepared? How many basic shapes are used to construct one single shape? That all the formulas, when we sum up, we will get the area of the irregular polygon. So I hope that this is clear. Let us clear more with few questions so that these questions become strong like iron. Let's begin with the questions. So here we are with the first question of our video 2. Let's see that what's there in the given figure ABCD in a quadrilateral. So this is a quadrilateral 4-sided figure. It's an irregular where AC is 24 centimeter. That means this AC, this line is 24 centimeter. Okay. Then BL is perpendicular to AC. That means this is the height. DM is perpendicular to AC. That means this is also height. So let us consider this as height 1 and this as height 2. Okay. Such that BL, the measurement of BL is 8 centimeter. That means height 1 is 8 centimeter. Same way DM is 7 centimeter. That means height 2 is 7 centimeter. And we have to find the area of the quadrilateral. Now this is the area of quadrilateral we are finding. It has been constructed with 2 triangles and I have derived the formula of area of quadrilateral. What's the formula? That the area of quadrilateral. And I have told to use the formula of area of quadrilateral taking base formula as half into base into height. So half. In this quadrilateral, what's my base? Base of both the triangles is AC and AC is my diagonal. Base of both the triangle is AC and AC is my diagonal into half into base into height. I'm having 2 heights, so height 1 plus height 2. This is the formula of area of quadrilateral. Half as it is, what's my diagonal? Base of both the triangles, that is AC, which is 24 into what's my height 1? That is 8 plus what's my height 2? That is 7. So if I cancel 2 ones are 2 12s are, so 12 into 8 plus 7 is 15. So when I add up, I will get it as 150 plus 30, which is equals to 180 centimeter square is the area of the quadrilateral. I hope that this question is very easy for you to understand. Right? So once we have derived the formula, then it has been very easy for us to generate the formulas without mugging up. And we have taken the reference formula as a half into base into height. Half into base. Base of both the triangles, which is AC, which is known as a diagonal, into sum of both the heights. Is it clear? Yes, if it's clear, you are enjoying like the pattern. Chalo, let's move towards our question 2. So here I am with the second question. That is also I have taken of quadrilateral only for your easy understanding. In the given figure, ABCD is a quadrilateral. As we can see, it's an irregular quadrilateral. Shape field is there in which diagonal BD, that means this BD diagonal 36 meter is there. AL is perpendicular to BD, that means this is my height, and CM is perpendicular to BD, that is this is my height 1 you can take and this is my height 2, and such that where AL is given to me, that is 19 meter, that means the measurement of height 1 is 19 meter. Same way CM, that means the measurement of height 2, that is 11 meter is there, and we have to find the area of the field. Now we know this field is of quadrilateral, so area of quadrilateral equals to half into diagonal into height 1 plus height 2. Half into diagonal, half into base, that is diagonal, that is half into diagonal into height 1 plus height 2, which is equals to half. What's my diagonal? That is BD, and the measurement of BD is 36, which is given, into height 1 is 19 plus height 2 is 11, which is very simple. 1s are 18s are, so 18 over here into 20 and 30 over here. So when we add up 3, 24, that is 54. that is 324, 54, 0 and 540 meter square is the area of the quadrilateral. The sums of quadrilateral are really very easy. Once you understand the formula, it's easy for you to solve. So I hope this is interesting. So let's begin with our third question, which is based on irregular polygon. Let's begin. So here we are with the third question, that is we need to find the area of the hexagon, and this is an irregular hexagon. So here we can see that this hexagon has been constructed with the 1, 2, 3, 4, 5 and 6 parts. It has been constructed, this hexagon has been constructed with the 6 parts. So let's find the area of all the parts individually and then add up all the areas to get the area of a hexagon. First, area of part 1, which is in a shape of a triangle, so the formula is half into base into height. What's my half? And base is my 6. What's my height? That is 8. 1s are 3s are. So if I see that 8 3s are, that is 24 centimeter. These units are centimeters, centimeter square. Then we will find the area of part 2, which is equals to, that is a trapezium. So formula is half into base 1 plus base 2 into height. So when we come over here, half as it is. Now this is a trapezium. Base 1 and base 2 is nothing but that are the sum of parallel sides. And in this trapezium, the parallel sides are this. Parallel sides are PF and NE. So base 1 is 8. Base 2 is 12. And height is nothing but the difference between parallel sides. If these two are my parallel sides, then the difference between that parallel side, that means this. Difference between parallel side is this. That difference between parallel side means 2 plus 8, that becomes 10. That means the height, the difference between parallel sides is 10. 2 1s are, 2 5s are. So here 20 into 5, which is equals to 100 centimeter square. Okay, fine. Now we will find the area of part 3, which is in a shape of a triangle. That means half into base into height. Half is half and base. Base of this triangle, that means 2 plus 3, 5 is my base, and height, that is 12. So 2 1s are, 2 6s are, which is equals to 30 centimeter square is the area of part 3. Now, we will find the area of part 4, which is in a shape of a triangle. So again the formula will be same, that is half into base into height. What's my half? Will remain same. Base is what? 6 plus 2, 8. What's my height? Height is 8. 1s are, 4s are, that is 16 and 32 centimeter square, because 8 4s are is what? 32 centimeter square. We will find the area of part 5, which is again in the shape of what? Again in the shape of trapezium, and the formula is what? Half into base 1 plus base 2 into height. Base 1 and base 2 is nothing, that is the sum of parallel sides. So how the parallel sides were this way? Same here also the parallel sides are this. So half base 1 is 8 plus base 2 is 6, and the height is difference between parallel side, that is 8 plus 2, that is 10. 1s are, 5s are, which is equals to 14 5s are. 5 and 20, which is equals to 70 centimeter square. So find the areas of 5. Let us write it over here, small letters, that is 84 square, then 100 square, then 30 square box, then 32 square, and fifth one is 70 square. Now we will find area of part 6, which is in a form of triangle, that is half into base into height. Half as it is. What's my base? 3. What's my height? That is 6. Yes, 3 and 6. 1s are, 3s are, 3 3s are 9 centimeter square. That means 9 over here. Now if I want to find the area of hexagon, area of hexagon, equals to part 1 plus part 2 plus part 3 plus part 4 plus 5 plus 6. Part 1 is 24 plus 100 plus 30 plus 32 plus 70 plus 9. So area of hexagon, when we add up, we get it 265 centimeter square is the area of hexagon. So I think that this is very easy for you to understand that how to find the area of the irregular polygons. When it is been divided into many parts, we'll find the area of individual parts, and at the last we will do the sum up of all the areas. So I hope this question is easy for you to understand, and now you are clear that how you can find the areas of irregular hexagons. Let us take one more example of this irregular hexagon to make your concept more clear. So here is the fourth question. You can see that once again I have taken an irregular polygon, and over there in the third question I have taken 6-part irregular polygon, but here I have taken only 2-part to make it more easier for you to understand. 2-part irregular polygon. This is part 1 and this is part 2. If you see the part 1, as I have to find the area of the enclosed figure. So you can see that first part is in a shape of trapezium. So we are going to write area of trapezium plus. Now this is square or rectangle. By seeing the dimensions, we can clearly see that this is an area of square. So plus area of square. What's the formula of area of trapezium? That is half into base 1 plus base 2 into height plus area of square side into side. Half as it is, base 1 is what? CF or FC, which is equals to 20. So 20 plus base 2 is what? 6. Okay, it's so easy. What's my height? The distance between two parallel sides, that is 8. Okay, plus side into side is nothing, 20 into 20. 2 ones are 2 fours are, that means 26 into 4, which is equals to 52, 52, 104 plus 4, 2 2s are 4, 00, 400. So we got very quickly that the area of this enclosed figure is 504 centimeter square. So I hope that this question is very easy for you. It has been interesting for you. So don't forget to hit the like button, and if you're new, then subscribe it for the upcoming videos. So this was the whole concept, that how to find the area of a quadrilateral, how to find the area of the irregular polygon. Moreover, we had also learned that when irregular polygons are given, then it has been divided into many parts. So first we'll find the area of all the individual parts, and then we will sum up. So in this video, we had derived the area of quadrilateral, area of irregular polygon, how to find. We have solved the sums to make your concept more clear. So we'll keep the video till here. We'll meet you in the next video soon with the more concepts in our series of mensuration. Stay tuned with me. Stay updated with me. Have a nice day. See you in the next video. Bye everyone.